Okay, guys, so compute, very important for the exam, compute. In compute, we have very important services, super important services, okay? Now, compute, compute has to do with numbers, you know? That's why we have computation, you have computers. Because it just works with numbers, okay? So, the overview of this module, we're gonna talk about compute services overview, Amazon EC2, EC2 cost optimization, container services, introduction to AWS Lambda, introduction to AWS Elastic Beanstalk. Activities, we're going to do Amazon EC2 versus managed service, hands-on with AWS Lambda, hands-on with AWS Elastic Beanstalk, demo recording demonstration of EC2, lab introduction to Amazon EC2. Guys, I don't think we have to do any demonstration with EC2 because I have done this very many times. So we don't have to watch a video. I can just do it again, and as simple as that. Okay. So now, after completing this module, you should be able to provide an overview of different AWS compute services in the cloud, demonstrate why to use Amazon Elastic Compute Cloud in Amazon EC2, and identify the functionality in the EC2 console. Perform basic functions in the Amazon EC2 to build a virtual computing environment. Identify Amazon EC2 cost optimization elements, demonstrate when to use AWS Elastic Beanstalk, and demonstrate when to use AWS Lambda, and identify how to run containerized applications in a cluster of managed servers. Guys, I can tell you that this is one of the most beautiful modules of this class, and one of the most important topics of AWS, compute services. Okay. Now, in compute services, we have several services, okay, that we're gonna talk in class. There are many, but there's some of that are very important for this class, okay? So the ones that we're gonna discuss in this class, in this module, are the ones that are highlighted, okay? We said that Amazon EC2 is a virtual server, right, that runs in the cloud, right? And if you can name it, you can say probably it's a server in the cloud. That's the most accurate definition, a server in the cloud, okay? Now, AWS Elastic Beanstalk, we know that it's a platform as a service, right? It's platform as a service that you just upload the code and it will build it, it will, provision it, and it will deploy it for you, okay? AWS Lambda is a serverless compute service, right? Serverless because it doesn't need a server, okay? AWS Fargate is a container service that doesn't require servers, okay? Whereas this one, Amazon ECS, is Elastic Container Services. It requires a server, okay? And they accomplish the same, but this one is even more efficient because it doesn't require a server. So it has less overhead, okay? Elastic Container Registry is the service that stores the images for containers, okay? So that's very important for you guys to know. Elastic Kubernetes Service is the Amazon EKS. It works with Kubernetes, which is a third-party container service, okay? So these are the most important ones for this class, okay? The other ones may be important for other certifications, but not for this one, okay? Amazon EC2 autoscaling is important, but it's more important for the solutions architect certification, okay? You just have to know that with the autoscaling service, you can scale in or scale out based on your needs. That's what you need to know, okay? Now, services, key concepts, characteristics, and ease of use. Amazon EC2 is infrastructure as a service. We know that already, okay? When you have a server, that's infrastructure as a service, and you have more control than platform as a service and software as a service, okay? In that case, we have in virtual machines, right? And it's instance based. Why? Because we are creating an instance, okay? When you create a server, that is nothing but an instance. That's it. an instance. Okay, when you create a database, that's an instance of a relational database service. Okay, you provision the virtual machines that you can manage as you choose. Remember, EC2 is an unmanaged service. It's not managed by AWS. Okay, a familiar concept to many IT professionals. Of course, if you are in the IT world, you know what a virtual machine is. Okay, AWS Lambda, serviceless computing. You know, serviceless because it doesn't require a server, whereas EC2 requires a server. It's a server. It's a virtual server. Okay, it's function based. So everything that you do with Lambda is a function. Okay, you have to get a function, and then the function will do something for you. Okay, and it's low cost. It's super, super, super cheap. It's not expensive. It's cheaper than EC2 instances, and you know, the experts think that in the future, Lambda will replace EC2 instances completely, okay? Because it's more convenient than EC2. You can write and deploy the code that executes on a schedule or that can be triggered by events. Use when possible, architect for the cloud. Okay, executes on a schedule is because you can use CloudWatch, which is a service for automation as well, and you can trigger a Lambda function with CloudWatch, or simply you can, you know, when someone uploads, for example, uploads an object in an S3 bucket, that will trigger a Lambda function, and it will send a message to the bucket's owner, telling them that someone uploaded something. Okay, so you can do that. It can be a schedule or it can be triggered by an event. Okay, and this is a relatively new concept for many IT members, but easy to use after you learn how. Lambda is rather new, but once you know how to how to operate it, it's gonna be super super easy. You should have some knowledge on coding to be able to work with Lambda comfortably. Okay, Amazon ECS, Amazon EKS, Amazon or AWS Fargate, and Amazon ECR, they're container-based computing, instance-based. So they use instances, right? Although Fargate doesn't use an instance, okay, because it's serviceless. You can spin up and execute jobs more quickly because you're working with containers. Containers super, 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 super fast and safe because they're isolated and self-contained. So it's for microservices, it's better to use containerized servers. Okay. AWS Fargate reduces administrative overhead, but you can use options that give you more control. Why is it reduces administrative overhead? Because you're not working with servers. Okay. AWS Elastic Beanstalk is platform as a service, like we say PaaS, and it's for web applications. So this is what you're doing. It's a web application with AWS Elastic Beanstalk. You focus on coding, which is building your application. You don't have to worry about anything else. Anything else will be done for you. Can easily tie into other services, databases, domain name service, DNS, that's Route 53, right? So you can integrate with other services with elastic load balancing, things like that. But guys, you don't have to worry about any of that. You could do some configuration changes, but you know, Elastic Beanstalk will do all for you. Right? Now, it's fast and easy to get started. It's simple. You just write the code and upload it. That's it. You're done, right? And it will take. It usually takes like probably 2 or 3 minutes. It may take more, depending on how long your application is, but it's relatively fast. Okay. So how do you choose the optimal compute service? It depends on some factors. Okay, and the use case. What are you using it for? Okay, so what is your application design? What is it? Is it a React application? Is it a Java application? Is it a JavaScript application? Well, actually, JavaScript and React. React is a library of JavaScript, but it is C#. It is Ruby. What are you using, right? So what is the design of your application? What is your usage patterns? How much are people using your application, your services, okay? And which configuration settings will you want to manage, okay? Now, if you select the compute solution, the run compute solution, it can lead to lower performance efficiency. You have to know how much power your application needs. So you have to understand that from the get-go, okay? So you have to understand the different available options that AWS has when it comes to compute times. So we have different, an EC2 instance here, you can have it as an application server, right? As a web server, database server, game server, mail, media, catalog, file server, computing server, proxy server. So you can have a bunch of servers with an EC2 instance. You just have to know which one, I mean, what application you are running, okay? You can have an EC2 instance as a database server, but you're gonna have more overhead, right? It's not the same as we spoke about before. It's not the same as our RDS. RDS is a managed service. EC2 is an unmanaged service. So it means that if you put a database on an EC2 instance, right, on top of an EC2 instance, then you have to download the database engine. You have to install it in your EC2 instance. You have to update it. You have to upgrade it. You have to patch it. You have to do a lot of things. Okay. So EC2 provides what? Virtual machines, and is referred as an EC2 instance in the cloud. So EC2 stands for Elastic Compute Cloud. That's why it's called EC2, two C's, Elastic Compute Clouds. It gives you full control over the guest operating system, Windows or Linux, on each instance. Don't forget that when we create our Amazon so when we create our EC2 instance, right? As you can see, when I close this guy and a few days from pass by, I lose all my favorites, which doesn't make sense to me. I had a lot of favorites here, but you know how it works. I don't. I can't complain. So this guy was running for a few days since what was the last day? Friday. So I still have some time, but it is not recommended to leave an instance running. Okay, not recommended at all. You only have 750 hours a month in the free tier, so be careful with that. So I'm gonna launch an instance. The first thing that you have to do is choose the operating system, right? Is right here. That's the operating system, right? That's the AMI, the image. It contains the operating system, the software. It provides Linux kernel of ultimate performance on Amazon EC2, the latest software packages through extras. It comes for 5 years support, and I can simply choose this, and then I have a Linux machine. Okay, so that's the operating system. Okay, so you have control over that. You can choose whatever you want. You can launch instances of any size into the availability zone anywhere in the world. So I can just choose the size that I want. This is the size. That's the instance type, right? And that's the size as well. So that will be this one, and then I would get to this section here, and then I can choose the availability zone when I want it. Okay. Remember that Virginia has 6 availability zones, right? North Virginia. So I have the 6 here, right? And North Virginia or Northern Virginia is US East 1. Okay, that's this section. So I can put it here in this, this subnet here. Okay, or maybe I can create the subnets before, right? And create 2 public and 2 private. And then when I get to the EC2 instance section, what I have to select, I can choose here the public or the private. And let me see something here. VPC should be down here. And then I have subnets, I have 10, right? I have 10 here, and they all are in the same availability zones. That's not good. So I want to probably see if I can edit this. Oh. Okay. EC2 instance. So I just launch it here and then select this and then this. And then I choose here my new VPC. And then here I can choose any of these guys, okay? But there's something wrong here. I put all the subnets because that day I was not showing you how to place it in an availability zone. So I chose the same availability zone, which makes this application not highly available at all because I'm using the same availability zone. So I should, for example, I should choose, for example, in this case, this subnet that is private, probably USB for this one and USB for this one. US East 1B for this one. And for this one, US East 1A and US East 1A. That's the way I should do it. So one or two subnets per AZ. That's the way it should be. Okay.
That's what we did in the lab.
That's what you did in the lab? Okay. Yeah. I did it this way because I was just showing you guys how to do it, how to create subnets. But in the lab, yes, you have to do one. And what is recommended is to have in every availability zone a subnet per EC2. If you have two EC2s, then the two subnets, two public subnets. Okay. Or two availability zones if you have two EC2 instances. If you have three EC2 instances, three availability zones. So that's the way it should be to make it more available. All right. So you launch the instance for Amazon Machine Images. Guys, don't forget that this is the core of your EC2 instance. If you don't have this guy, you cannot create an EC2 instance. You can't. Okay. You launch the instances with a few clicks or a line of code, and they are ready in minutes. So you can control traffic to and from instances, right? All right, so we continue. So we have this section here, something, guys, that you already know, but don't pay attention to this so much because this is the old console, okay? This is not the new console. The new console looks differently, okay? So it looks different. You see, it is not blue, the button is not blue anymore, it's orange now, and it has a different view. It's not the same, okay? But still, you know, I think there's a section here that you can change to the old one. I don't want to give any feedback. This is the old one, okay? This is the old look, not the same. I got used to it, but it doesn't look as nice and clean as the other one. And of course, it doesn't have any new news here because this is old. So I better go to the new EC2 Instance experience, and then it looks a little bit better, maybe a little more organized than the old one. Okay. And it's obviously a new one because it's welcome to the new EC2 Instance console. Okay. So guys, you know how to find the button to launch the instance, right? And then you have an idea here what instances are running, if there's any, if you have any key pair, any security group. So this is a good spot to just determine if something is probably running unnecessarily. Okay. In this case, I have 3 key pairs, right? So I am not using any of these guys right now. So what I'm gonna do is delete the key pairs. So I'm gonna make sure that I delete them and they're gone. All right. I'm gonna show you how to do this, from the console, from the terminal, right? So along the way, essential Amazon institutions concepts will be explored. Okay, continue. So AMI, what is the AMI? It's a template. It's a template that is used to create EC2 instances, um, and it runs in the cloud. So contains a Windows or Linux operating system. That's what we saw already, right? And also it has some software pre-installed. So whatever software that Linux machine needs, it's already pre-installed. Okay. Now you have a quick start. There's other choices provided by AWS. My AMIs, any AMIs that you created. AWS marketplaces, you can buy images from there, right? And then the community AMIs, shared by others, use as your own risk. So it's not recommended. Okay. So maybe I want to create an image, right? So I'm gonna launch an instance here. Probably I can just my AMIs, right? And maybe I can have a quick start here, right? Or maybe I can, okay, I can come here and see here in the EC2 instance where it says my AMIs, right? And then I can, create an image here. And then this is even more complicated than before, right? But you can create an image here, right? But it's very self-explanatory. Okay? So you can choose the operating system here. I want to choose Amazon EC2 instance, Amazon Linux. Maybe you want to browse some components here. Okay. And maybe want to keep it simple. So at least one build component must be specified. Okay. And what do we have here? Okay, created by me, Amazon own. Okay. So I want to choose this one, right? And then I have that guy there. And then browse to select tests, browse test. I can choose that one. And then what do we have here? Valid source image IRN. Okay, so browse images. I have these two here. I want to choose Amazon EC2. Okay, I choose that one. And then I have this guy here. And then it's gonna have this 8. This is like a template of your EC2 instance, right? So we have this guy here, add new EBS volume. I don't want that. I can add that when I create the instance. Okay, so now I can do this. I'm gonna give it a name, say my AMI. Okay, the description is this is a custom AMI created by me. Okay, I know I don't need any role for this. I can create this to manual or cron expression. I don't want that. Instance type. I want to choose T2 micro, which is the one, the one included in the free tier. And SNS topic, I don't need an SNS topic. This is the simple notification service, which is to send notifications to subscribers. I don't need that, so I can do next. IAM role for the instance profile must be specified. Okay, so create a new topic. And then I will create a new, do I have to create a topic? Oh, no, that's in the role. Okay, where's the role section? Did I miss it? Instance type here. Oh, create a new instance. Let me see. I have one that says EC2 something. EC2, EC2, EC2 Solanga, EC2 instance role. This is ECS. My first EC2 role. Okay, that's fine. And then I can do next. Just this is very complicated. Before, so it was so easy. I don't need that. Let me see. I put AMI. For AMI name and then okay. New AMI pipeline name, right? And then this is gonna be public. Let me make it private. Okay, private is private. Okay. Review it. I view my image, and I create the pipeline. Okay. Oh, so I have my AMI here is enabled. Okay, so whenever I create an EC2 instance, let me see if it works now. EC2 instance, I launch it, and I should see something under my AMIs. I don't see anything. Okay, this is a pipeline. Okay, images, and then created by me. All right, guys, this is all new. You know, it's these people, they keep constantly changing this, and it was so seamless before. Right now, it's even more complicated than than it was before. So I have this guy here. It's a recipe. Okay, and then delete recipe, create new version, create pipeline for this recipe. Okay. All right. Well, let us not worry about that now. What we have to understand is the AMI is what is new for this. Okay. I'm not used to creating images. I just get the image from the ones that AWS provides right here when you create this EC2 instance, and then I always use this one, which is very common. If you want to create one, then that should be for another certification, maybe DevOps or developer. Okay. Or maybe solution architect. Okay. So AMI details, right? So we have an instance type here. We have the region. Sorry, sorry guys, it's my mouse. It's very sensible. So we have AWS. Oh, I can touch my mouse. All right, so AWS here, cloud, and then we have region A, quick start or other existing AMIs, starting AMI. You launch an instance, a modify instance, then you modify the instance when you connect to an instance and manually modify it or run a script that modifies the instance. Remember, guys, when I install an Apache server and I put code in the user data, so I modify the instance when I put that. Then I can capture as a new MI and have a new MI. So when I have an instance, right? And right now I think that I don't have any because I think I deleted the one that I had. Okay. If I create an instance, right? I can do this and then just launch it. I don't need about anything else. So I can just without a key, I just click here and then launch the instance, right? So I can wait for this instance to, create, right? All right, so when it is running, right? Still pending. There's nothing I can do, right? If I come here and say instance setting image, I can create an image from that, right? And then I can name it my image, right? And then I can enable this no reboot. I don't care about that now. So the one that I have right now has an 8 gigabytes. So that's gonna be exactly the same for the new image. So I have this image here. If I come to this section where it says images, then I have this guy here, okay? That is already being created. So I just created an image from my own EC2 instance. So I can share the image with someone else, but something that we have to understand is that images are region-based, okay? So I can wait for this to be in the available status, right? And then I can use it to create another EC2 instance like that one. But I have another choice here. I can do this, and then just I have a choice here. It says, see, create launch more like this. So I can create another instance exactly the same. Click launch, and that's it. That's one way to create another instance. But maybe you want to share your image with someone else. It's like sharing an ISO image with someone. Similar. Okay. Now, if I take a look at my images, it should be created by now. Still pending. It may take some time, depending on how big this image is. Okay, so let's continue. So I can capture a new AMI from the EC2 instance, right? And then I can copy the AMI to any other regions where you wanted to use. So you have to make a copy of that. You cannot share the same. You have to make a copy. Okay. So I can just, let's wait for that to be available. And then I should have this copy AMI option here. And then you can copy that AMIs and send it to someone else. Okay. And then you can have this in another region. Okay. So optionally import a virtual machine. You can import that if you want to. Okay. So this is taking more than usual. It seems that it's a big one. Okay, let's continue. Now we have the instance type. Okay, this is just the process that we just saw, guys. Okay, so I'm gonna just go through it quicker because we've done several times. I just created an instance and I went through all these guys. Right? The memory RAM processing power, that's the instance type. Okay. In this section here, you can see that the instance type is right here, right? Is when you select this guy, this is the instance type section, okay? First, we have the AMI, that's the first step. Then you have the instance type right here. And then you're gonna have there in memory RAM, processing power, CPU, it's right here. CPU, RAM, all that, okay? Network performance is right here, okay? Then instance types category, you have general purpose is right here. This is the one that I use for everything. It's a general purpose one. You have the compute optimized, just in case you need more compute power. So you have, if you scroll down, you're gonna get to a point where you say compute optimized. It's right there, compute optimized. Of course, this is a free tier account, so we don't have those available. Okay, and then we have memory optimized. You just scroll down, for the ones that need more memory. Okay, so let me see memory optimized right here. Okay, a storage optimized. We continue just scrolling down, and we have the storage optimized right here. As you can see, they have everything that you need: accelerated computing. Instance type over family, generation, and size. Family, generation, and size. Okay. If it's generation, current generation, or all generations, or instance type, right? And the size, all generations, micro instances, generally purpose, you know, different generations and different sizes and families, all that. Okay, so instance type details T3 large. T is the family name, 3 is the generation number, and large is the size. So right now we're using what? T2 micro. That's the one that is included um, in the free tier. Okay, so T is the family name, T, and then we have what? The generation number, right? And then the family, the size, right? Micro. Okay, right? Family, generation number, and size. Okay, so these are from the family three T3, right? And the generation 3, and the nano is the size of that. Okay. Instance type details, guys. You don't need to know this for this exam. It's just to have an idea of how they work. Okay. Usually the ones that start with a C, it means that they are compute optimized. Okay. Compute optimized. So we have these guys here, instance type and use cases. When it's broad, use these guys. When it's high performance, use this. In-memory databases, use this. Machine learning, you use these guys. And distributed file systems, you use these guys. Okay. So even AWS gives you some instructions and guidance as to what, you know, type to choose, so that you don't, you know, waste resources and just have the one that your business needs. Okay. Instance types, networking features. You know, the network bandwidth is gigabit per second. You know, you have it here in this guy here. So gigabit per second. That's the performance. Indicates the performance level, the rate of data transfer, right? See Amazon instance types. That's what we're seeing here. These are the instance types. So we don't have to click on that link. So to maximize networking and bandwidth performance of your instance type, if you have independent instances, launch them in a cluster placement group. So you have cluster placement groups. Those are things that you can choose when you create an EC2 instance, right? You could put your instance in a cluster if you want to make it more highly available. That's one of the reasons why you put that in a cluster. So there's some section here when you select this and you go to the third section, there's something here that you can choose, put it in the placement group or not. Okay, right? So you can add a new placement group and then you can just give it a name. And in this case, you're going to choose spread or partition, right? So you can choose here, maybe add to existing group. I don't have any right now. There's one section that says placement groups where you can create one. Okay. Right here, placement groups. Okay, right here. Okay, so you can create one placement group. I have one here already. So this one right now is, okay, it's a cluster. Okay, this is a cluster, but I can create one, and then I can say my other placement group. This is to put your instances more organized, right? You can choose a cluster, spread, a partition. Partition has more availability than these two guys. This is more advanced, but let's say that we want to have them all in the same rack. Okay, cluster in the same rack, all the EC2 instances together. So I can create this group. And then when I choose the EC2 instance and I create that, right? I can just come here, and when I just jump to the third step, I come here and I choose, let me put in a placement group, and existing, I don't have anything here. As an instance, group to benefit from greater redundancy and higher effort, okay? An existing and new, I don't have, they don't show here. Maybe I can add a new one here and choose partition or spread. I can choose to put it here. Okay, placement groups. Sometimes I lose it here. Okay, so this one, the one that I just created. Okay. So cluster. Let me choose something else because cluster is not available there. Let me just delete these two guys because I don't need them. So let me delete them. Okay, delete. Let me copy this guy because I'm going to use it again. And then let me delete this guy. I'll just copy and then delete it again. Let me create a placement group. And then now, instead of using cluster, I'm gonna use spread. Okay, let's say my placement group. Placement group. Okay, and then I choose, let me choose spread. Okay, that option is going to be available. Okay, now if I want to see placement groups in AWS, right, it's going to tell me the 3 types of placement groups. Okay, so I have cluster, partition, and spread. Okay, cluster is a logical grouping of instances without a single availability zone. So that's not highly available at all. Okay, but some people don't like availability. I mean, they don't care about if their instances are highly available or not. So when availability is not a problem, you can use cluster. Okay, it can span peered VPCs in the same region. Instances in the same cluster placement group enjoy higher per flow throughput limit for TCP and IP traffic and are placed in the same high bisection bandwidth segment of the network. So it's super fast, but it's not highly available. So if this availability zone goes down, then boom, you're doomed. All right. Now partition, as you can see here, the availability zone is partitioned in 3. Okay, it's partitioned in 3, so it's more highly available. If this partition goes down, then these two are still working. Okay, so it helps reduce the likelihood of correlated hardware failures for your application. When using partition placement groups, Amazon EC2 divides each group into logical segments called partitions. Amazon EC2 ensures that each partition within a placement group has its own set of racks. Each rack has its own network and power source. No 2 partitions within a placement group share the same racks, allowing you to isolate the impact of hardware failure within your application. So this one is more highly available than cluster. Now spread, look at this, right? It's each one is in different distinct rack. Okay, so you can put these 3 in one rack, these 3 in one rack. In this case, each instance is in a different rack. Okay, so when I get to this part here, when I choose the create the instance, I can launch this guy, and then when I get to the instance, it should show now, because cluster was not available, but spread and partitions are. So let's use this here. 16 right here, spread. Okay, so I can put up to 7 more instances, right? So I can have 8 instances in this placement group. Okay, I can have up to 7 running instances per availability zone. So you can see here that these guys are going to be in the same availability zone, but they're going to be in different racks. Okay. Well, actually, the spread is the one that is different racks, but it's not like partition. Partition, you have like 2 or 3 EC2 instances in different racks. Okay. So these placement groups are very important. Okay. If you have independent instances launching in a cluster placement group, enable enhanced networking. Okay, that's what a placement group is. Okay. So enhanced networking types are supported on most instance types. See the networking storage features for detail. So sorry. Enhanced networking types, elastic network adapter, ENA supports network speeds up to 100 gigabits per second. And we have this Intel 82599 virtual function interface, support network speeds up to 10 gigabits per second. Not information that you need to know for this certification. So network settings, we have, you put your EC2 instance in a VPC, don't forget that. And then if it is a web server, you would put it in a public subnet. If it is a database, you would put it in a private subnet. That's something that, you guys know already. It should be, okay, if you put this in this, when you create this guy, you can enable auto assign public IP. Okay, you can enable this. So you're gonna have a public IP every time that you create an instance or you stop an instance. So guys, if you want to try that, create an instance, you know how to do it already because you've seen me how to do it. And stop the instance and then watch how it has a new IP address when it starts again. That's a normal process. But it could be a little difficult for someone trying to access your website with an IP address, because if it is always the different one, you cannot use the IP address to access the website. Okay, so you will have to use the DNS, which is basically the URL for that. Okay, so if you want to have the same IP address all the time, what you have to do is just create an elastic IP and attach it to the instance, and that's it. It will stay there forever until you disassociate it from that instance. Okay. The IAM role, we already know that IAM roles are for, to facilitate interaction between services, right? You attach a role to an instance, and then the role assumes the role. The instance assumes a role, and then the instance, for example, we have access to an S3 bucket because it has a role that allows the instance to have S3 bucket access. Okay, so that's how it works. Okay, so there was a role here that I created last week. I think it was EC2 S3 with EC2 interaction. So I would choose this guy here, and then the EC2 instance we have access to the S3 bucket. They can interact with each other. So that's how it works. Okay, so simply you attach a role to the instant will assume the role, and then that interaction is possible after that. The user data is the section where you add the code and you modify your instance. Remember that last week, I think it was last week. Yeah, last week, or probably the week before, that I added an Apache server. Remember, guys, that I did it? And then I used the DNS, and it says hello from this host name. Remember, guys? Do you remember or not? Probably. Yes.
Yeah.
Yes.
I would remember. You would remember.
Yes, sure.
Yes. So this the user data is the section is right here in the same page down here. This is where you install things, right? And usually, you use a bash script, right? And then you can do whatever you want to. You can install an Apache server. Of course, this is a Red Hat distribution. That's why we're using this YUM thing. If it is Debian, it will be apt. Okay, that's a package manager. By the way, this is a package manager. We are using a package manager to download packages, right? So this Y here, what it does is just answers for you. Remember when you download things, sometimes it asks you yes or no, you want to continue? So we put this option Y, it is going to answer yes for you, so you don't have to stop the installation to say yes. And then you don't have to do that. So we can just update first. If you do update, it will update that EC2 instance, whatever update is possible. And maybe you want to install an Apache server. I say Y install HTTP TPD. I think, let me see. Okay, let me see here. So there are different ways to do the same thing, but I have it here very clearly, so I don't have any issues during the installation because I don't want to go back and check that again. Um, okay, I have here. So I am doing this guy here so I can do HTTP x86 underscore 64, and then I can do system that's this command in Linux, because this is Linux. This command it's for enabling, disabling, starting, stopping processes. Because inside your virtual machine, there are going to be processes. Every time an action is started, there's a process behind the scenes running until the process ends, right? So we're installing HTTPD, we have to start that service, okay? So we're going to do start and then HTTPD service, because when you have a service, they usually end in D, right? And then now we do system CTL and we say enable it. And then HTTPD service, right? And now we're gonna say something cool. We're gonna say, for example, echo, and we say some HTML thing here. Let me put style. Style. Let me see if I remember HTML things. Say color, and that's red, right? And then say close this guy, and say hey, 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 I'm here. Something funny. All right. Let me style, color. Okay, that's fine, right? Color.
Yeah, that's fine.
Right? And then I redirect that to a file. Okay, that's gonna be inside the var. Okay, the vars folder. And then inside the var folder is gonna be another one. This is all default. When you install the HTTP service, Apache server, then all these folders are created for you. Okay, and then inside the www folder, there's gonna be another folder named HTML, because an Apache server is a web server, okay? And then there, I'm going to create a file. I'm going to name it HTML, index.html, and that's going to contain this guy, okay? Now, I'm just going to move forward, right? Storage is fine. Add tagging, I'm going to call it name web server, okay? Web server. Let me put the actual size here. Then configuration, I'm gonna use, let me see if I have one guy that has the 2 ports that I need. This one has 22, this one has 22, 22, and 22. Let me create one, okay? Create a new, let me see, web server security group. And then say web server, I'll put the same thing here. Okay, and then this allows SSH access, and let me select HTTP, right? And I'm gonna say this is good for IPv6 and IPv4 and IPv6. That's good. This allows web browser access. Okay. Okay. So I'm going to say here my IP, because I don't want any other anyone else to access my account unless me. Okay. So I'm going to say launch. Okay. Guys, remember that this has some limitations. If you try to connect to this EC2 instance connected to another network, you have to change this, okay? So if you do this at home and then you go to another IAM network, you have to change this. Otherwise, you will not be able to connect, okay? So I'm gonna come here and I'm going to launch this guy. But now I'm going to create a key. Okay, I'm going to say new key for today. Okay, I'm going to download it here, and then I'm going to launch the instance, right? I'm going to bring this guy here where I can see it, you know, and I put it here. Okay, I'm going to delete this guy. I don't need it. And then I guess that I can, you know, grab the IP address and see if that print that I got, you know, web server here, I can just grab that IP address, which is right here, you see? And the bad thing about having an you know, a dynamic IP address assignation protocol is that if I stop this instance, I lose this one. So the guide that will remain, always remain, is this one. So this is the guide that I should always use. Okay. So if I just copy that, sometimes it takes some time. Okay. And if it doesn't, if it refuses to do that, I can simply, you know, what's going on? Nothing. I can probably check the EC2 instance and see what's wrong here. Okay, maybe I can just check here the user data, right? I can come here to the user data and see if that's exactly what I have in my computer. Okay, so I can do bin bash update install HTTP 64 systemctl start HTTP service, enable HTTP service, echo. Hey, var, HTML. I don't see any problem there. Let me see. So if I want to update that or modify that, I will have to stop the instance. Otherwise, it's not going to show. It's going to be graded out, so I cannot do anything. I had to stop it, and then when it stops, I will be able to modify it. Okay. So I just lost control of my mouse again. So far, it was so good. Right now. Okay. Okay, good. So now it stopped. I can come here and just come to the settings and modify this guy. Modify that, and then I can say, okay, let me copy what I have here so I don't have to think so much. So I can do this here and then copy this guy and save it. Now that I saved it, I can start the EC2 instance again. Okay. Let me do something. Let me grab this ID from here. And then I can start. Okay. Okay, I can do this. I can do something here from the command line, right? And I can do something here like probably, I will not do it now, guys. Probably after the break. Remember that I deleted my keys, so I have to reconfigure my CLI. So I'll do it later. Okay. So let's continue with this. Let me just grab this guy again, and it should be running now. Did I start it? No. So let me start it again, and then I will do that from here. Okay. I can do it from the CLI, but I have to configure my CLI. Okay. So it's pending now. If I refresh it, it's running now, so I can grab the IP address. Well, what's running, right? Okay, I can grab the IP address or this guy here, right? And then I can come here. It should work now. It is not printing anything. Okay, weird, because I did exactly the same as we did last time. I'm not doing anything new. Let me copy the IP address and see what's going on here. It's not doing anything. And I believe it probably has to do with the browser, or sometimes when I do it with a Windows computer, it works faster. With the Mac computer, sometimes it takes time. For some reason, I discovered that in the past. Okay, but it worked the other day. I just did exactly the same as I did the other day. It's not working now. I don't know why. And I don't want to stop to think what's going on right now. But that's the way it is, guys. You just put the user data there, and then just run your EC2 instance, and it will at runtime install whatever you put in the user data. Okay. So the storage option, you have the root volume, is the one that comes with the EC2 instance. By default, is 8 gigabytes, and a gigabyte is smaller than a gigabyte. It's like 1 gigabyte is 1.4 gigabyte. So there's a measurement for space and size that it's very popular nowadays. Gigabyte, tebibyte, megabyte, okay? But the size is in gigabytes, and the volume type, you have the volume type, and if it is encrypted or not encrypted, okay? So you have the choice to encrypt it, okay? The problem that you have, this one doesn't have an encrypted volume, okay? So the one that it's here, it has a volume that is not encrypted. So if you come down here to volumes, okay, and you see that these guys are not encrypted. You see here, they're not encrypted. What you can do, just in case you want to encrypt a volume that is not encrypted, you can create a snapshot, okay? And then the snapshot, you can call it my snapshot, right? And then you create a snapshot of that particular volume, which is like a screenshot of that volume, okay? So I can create a snapshot. I can come here to my snapshots section, and I will see that the snapshot is being created, right? So you see it's not encrypted, it's not encrypted. So let's use this one that is already created, okay? So I can create an image from this guy. I can create a volume if I want to. Remember that a snapshot it's a snapshot of your EC2 instance. So I can create a volume here. And now when I create a volume, I have the option to encrypt the volume. So good thing about this is that you can create a volume from an encrypted volume, taking a snapshot of that volume. I don't know if you understood that tongue twister, guys. When you have a volume that is not encrypted, you take a snapshot of that volume, and from that snapshot, you can create another volume, right? And then you have the choice to encrypt it. But once you select the volume, if you're not encrypted, if you don't encrypt it, you cannot encrypt it, you cannot edit it, right? You will have to create a volume from that snapshot, and then you can have this section here set encrypted. And now you can have the master key that comes with by default by AWS, right? And then you can encrypt it, right? And then you can create a volume, right? And now if I take a look at the volume section, this one is being created and is encrypted. You see? And now with this volume, you can create an EC2 instance, right? with this encrypted volume, which is exactly the same as the one that was not encrypted. Okay, so if I click here, right, and I say create a snapshot, delete volume, modify, attach volume. You can attach a volume to an instance. Okay, so I can click here and it is available right now. These two are in use. And these two are the ones that are attached to the web server and the other one that was created previously. So I can attach this volume to an instance, right? And there's no running instance in this availability zone. So volumes are by availability zone, okay? So I should have created this volume in a different availability zone because these two are created in D, okay? So what I can do is maybe create, this is a volume, create another volume. Let me come here, take a snapshot, right? And call it my other, maybe my other snapshot. And then create a snapshot here. So it's now, if I come here, maybe, okay. You see, I have the choice to select that. So the volumes are availability zone specific, right? So I have to see my instances where they are created. They're created in in this 1D, right? 1D. So my volume has to be 1D. So I can come here where the snapshots are, okay? And from this, this one is pending, or maybe not the pending one, the other ones that are already created. I can create a volume from this snapshot. This one, for example, create a volume, and then I can choose 1D, right? And then I can encrypt the volume, and then the master key, I can just choose the default one and create the volume, okay? So I can just come back to the volume section where, okay, volume right here, and this volume is being created. It's in creating status, right? So if I just, this is available right now. Now, if I want to attach that to an instance, then I can come here and say, this instance is running, and this is it. I can do this, and then attach it to the one running, okay? And then it's gonna be mounted on this specific file folder, and then I attach it, right? And now my web server, if I click on that, my web server will have, let me see if I should select another one here. Okay, let me come here to my EC2 instances, right? And then my web server, if I select it, right, I'm gonna have storage. I'm going to have these two volumes that are attached. Okay, so right now, my EC2 instance has a lot of power, a lot of storage. It has two volumes of 8 GB each, right? One is encrypted, and the other one is not encrypted. Okay, so we have something here. We have something here. This one that is not encrypted will be terminated with the instance. Okay, when you delete the instance, this one will be terminated. That's called instance store. The instance store eliminates everything. It's like RAM. It's like storage that's RAM, right? When the instance is terminated, the root volume disappears. But this one that I just created is gonna stay there forever until I delete it. So delete on termination, no, it's encrypted. So this guy is a good guy, okay? The one that I just created. So you can attach to an EC2 instance as many volumes as you want, but bear in mind that you're gonna be attached more, you're gonna be charged more money. Don't forget that. Okay, so let's continue. Good thing.
Question.
Go ahead.
How resolve if you have one is encrypted, another one no? How resolve the storage? Who decide?
No. You should have it. You should have all of them encrypted. Okay. I just leave it out this way because I don't want to continue with this. But this one, when you create the instance for the first time, you can encrypt that one. So we can say here, and you create an instance right here, right here. We can say, just let me just fly through the steps, okay? And then when I come here, I can encrypt it, right? So I can encrypt the root volume if I want to. So if I have one unencrypted and one encrypted, that poses a conflict. So
yeah, that is my question.
yeah. I should have it, everything encrypted, right?
Okay.
Encryption is free. You don't pay anything for encryption. So security is free in AWS up to certain points, okay?
Architecture question. Is the hardware level description like the normal storage, or is a different layer they have for encryption?
This is an additional layer.
Mm.
The hardware is something that AWS takes care of that. Remember, you are responsible for the security in the cloud. AWS is responsible for the security of the cloud.
Okay.
Okay. So let's continue. Moving fast. Okay. Very productive day. Okay. So store options, durable. Amazon EBS, we know of that already. Is durable block level storage. You know, we talked about that in the first day of class, the second day of class. You can stop the instance and start it again, and the data will still be there. Okay. When you stop the instance, this root volume doesn't disappear. Okay. Because you know it's gonna stay there, right? But if you terminate the instance, it will disappear. I'm talking about the root volume that comes with the instance. I'm not talking about the ones that you attach. Okay, that's called instance store, right here, instance store. Okay, it's ephemeral. It's provided on disks that are attached to the host computer where the EC2 instance is running. If the instance stops, data stored here is deleted. If the instance stops, okay, but this is not the instance store. This is a root volume. This is different, okay? An instance store, that means you may have that in the exam. When you have an instance stored EC2, if you stop it, the data is lost because an instance store is nothing else but RAM memory, okay? It's an EC2 with the RAM memory. It will keep the memory as long as the instance is running. Once the instance stops, you lose the data, okay? But with the root volume, it will stay there until you delete it or you terminate the instance, okay? That's what happens here. You can stop the instance, start it again, and then it will be still there. Other options for storage, not for the root volume, mount on an EFS, right? EFS, remember, share file system. You can mount that on the network and several instances can share that file. Or you can connect to an Amazon S3 bucket, which is, you know, super durable. It has an 11 nines durability. And when you say 11 nines durability, it means that it will lose data once every 10,000 years. That's what it means, okay? And of course, if you just do the math, it's not gonna lose. It's not gonna lose data as long as you're alive, right? All right. So instance one, characteristics of instance one. We have here, it has an Amazon EBS root volume, right? Sorry, one moment. Oh my God. So type of the operating system. What will happen if the instance is stopped and then started again with the root volume? What would happen? What happened if the instance stopped and then started again when it has an EBS root volume? What happens? Do you have an idea, guys? What happens if I have an EBS root volume in my EC2 instance and the instance stops and then starts again? What happened to the root volume?
Data is erased. Data is dropped.
Are you sure?
No, that's the
I
block
just
there,
said,
so it remains.
It's ephemeral or no ephemeral.
I just said that if you have a root volume, you know, you can start again and the data will still be there, right? But if you have an ephemeral, which is an instance store, then if you stop the instance, you lose it. You lose all the information. Okay. So you can have several EBS volumes attached to an instance, but it's one instance per volume. You can have the same volume attached to two instances. You will have to detach it and attach it to a different instance. It's not possible to attach one volume to different instances, but one instance can have different volumes, okay? Tags, you know, you saw me add tags to the web server. You saw me that I put here in the instance. If you take a look at my instances, right now I have this web server. This is a tag, very important for this is very important for billing. Okay, for billing is very important because you know you can find resources you know through tags easier than without tags. Okay, so it consists of a key and a value pair. Okay, tagging is how you can attach metadata to an EC2 instance. Potential benefits of tagging: filtering, automation, cost allocation, and access control. So you can filter services by tag. Okay, and one of the services that you can use for that is Systems Manager. When you want to, for example, you want to add an update to all the development instances, you find them by tag because they're named development. So you can update all the instances at the same time through tagging. Okay. The key pair, the security group, you know about security groups, you know, you open the ports, you know that they are stateful, you know, what comes in goes out, right? And you don't have to work on the outbound rules, only by, you know, editing the inbound rules. That's all you do, nothing else, because by default, all the traffic is denied, right? And then you do that, you just allow open ports, and then you allow traffic in, and then that what is allowed in will be allowed out. Okay, so you specify the port number and protocols such as transmission control protocol, TCP, or user diagram protocol, UDP, or internet control message protocol, ICMP. Specify the source, for example. Oh, okay, right, continue. So what do we have here? The keys, you know the keys, guys. So it has a public key and a private key, right? And with that, you can SSH into an EC2 instance, okay? Piece of cake. Here we have the view of the console, right? This is the old view, right? We have a different one now. This is a way to install, you know, things programmatically. Okay, this is the way that you create EC2 instance from the CLI. Okay, so once the user is given access programmatically, then the user can configure the CLI like you did on the first day of class, guys, and then you can use, you know, the data to create an EC2 instance. So you will need this, right? This EC2 command. All the commands for EC2 is always the first element of the command prompt or line. The anatomy of that is the first is the service. I mean, the provider is AWS, right? And then the second one is the service that you're going to be working with. And then the operation you're going to be performing, right? And this / with space, it means that you can put several lines one below the other. If you don't put this backslash, I'm sorry, you're going to have an error. So this, what it does is break the line and still reads all these options here. Okay, so you're gonna see in dash dash image dash ID. Usually when you have two words, you push a dash, you put a dash in the middle. But the first word is gonna have that dash dash. Okay, the instance type C3.large, the count one because we're creating only one. Remember, or just bear in mind that you only have a limit of 20 instances per region. Okay, so you cannot create more than 20. Okay, as a new account, of course, you can have that increased, that limit increased as you progress and uh, show that you're a company well established and things like that. But as a new account, you can only create 20. You have to create 20 in another region, not in the same region. The key name, you're gonna probably use this key name, the key pair name, and that's going to create a key for you, right? The security groups, you can use my security group. This is one that's already created, okay, right? And then region US East -1. Okay, so you're gonna create this in Northern Virginia, okay, and then you can check that. These are the different stages of an EC2 instance, right? It starts with pending, right, and then running, right? When it's running, you can stop it, and it's in the state of stopping, right? And then it shows stopped, right? Then you can start again. You can start it again. It goes back to pending, running, and if you don't stop it, you can terminate it. You can also hibernate it, right? You can terminate it, and then when it's been terminated, you click on terminate instance. It is in the stage of shutting down, and then it's terminated. Okay. Also, when it's stopped, you can terminate it too. And how do you know this, guys? By experimenting and exploring your console. Okay. Try to play with that. Try to play with that. First of all, the first step you need is to have an AMI. If you don't have an AMI, you cannot launch an instance. Okay. You can reboot the instance as well, right? So this is for only instances by Amazon EBS. Okay, if you have an Amazon backed up by store, instance store backed, that's going to have a different treatment. All right, this is for EBS. What time is it, guys? Oh, it's 7:02. Wow. So let's take a 10 minutes break, and then we're going to be back here at 12. Do you have any questions before we go on break? No?
Yes,
No.
I was
Mm-hmm.
making one exam. I found about the predictive. Uh, it's about the feature about name predicted for EC2. Could you explain more about this feature next?
Predictive for EC2. I don't know what you're talking about.
Yeah. Okay.
I will have to do some research on that. Okay, I haven't heard that.
I see in the mocks exam. It's a question about this feature.
In what exam? Where?
The mouse.
Oh, test
It's
mock.
a number one.
Oh,
Yeah, number one.
Okay. Predictive.
It's a new predictive scaling for EC2, powered by machine learning.
It predicts the future traffic. Okay.
The first time I saw that feature.
Including regular occurring spikes and provisions the right number of instances in advance of anticipated changes. Provisioning the capacity just in time for an impending load change makes auto scaling faster than even before. Okay, so it's more powerful than the regular auto scaling because it can predict the future based on trends. Okay, and of course it can have a predictive scaling policy. Okay, that should be somewhere here. One moment. Let me see if I can find it here. So auto scaling. Okay, auto scaling. Okay. Just getting here. And then you can create, okay. So we have to first do a launch configuration, and then I can create a launch configuration in my other launch configuration. Okay. And I can choose an AMI. I can choose the one that I have right now, right? A launch configuration is like the skeleton of the instance, okay? So I can choose T2 micro. T2 micro, where's T2 micro? T2 micro, okay. T2 micro, okay, choose, and then request spot. It's like the skeleton. It's exactly the same as we create the instance. The role, I'm gonna choose this one now, the same that I had before. Just, I don't need to choose a role, but I just, I can launch that as an EBS optimized instance. I don't need that. The volume is gonna be this one. And then this guy is going to create exactly like replicas of every single EC2 instance, okay? I can create a key here and then use them all. So I'm not gonna just choose proceed without a key and then launch the configuration. I can acknowledge this and then launch the configuration. All right, I'm gonna use this configuration to create identical instances. So I can create here an auto scaling group, and I'm gonna call it my other auto scaling group, right? And then here, I'm gonna choose switch to launch configuration. I'm gonna choose my other launch configuration. This is gonna have these characteristics here, right? I do next, and then I'm gonna create that and my VPC, the default one. I don't wanna choose anything else. And then, where this is, okay, let me see previous. You can choose next. I can choose here my new VPC if I want to specify a particular instance. So I can do here my public IP1, and then I can do my public IP2. Okay, these two are gonna be created here. Okay, and then right now I can do enable load balancing. No, I don't want that now. I can do next. The capacity is gonna be, desired capacity is gonna be 2 probably, and the minimum capacity is gonna be 2, and the maximum capacity 5. Okay, and I have these policies here. Target traffic policy. No, I know. Okay, and then I can do next. No, no. And then I can scaling policy, no scaling policy. I can create auto scaling group. Can I create one or more security groups in the launch and that lead to a VPC? Okay. So I can do, yeah, I can edit this and choose my default VPC. Okay, and choose one here, you know, another one here, and that's it. So next, 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 and then launch. Okay, that works now. So right now, I can have these guys. So automatic scaling, scaling policies. I can add a policy here. Step simple. Okay, this is gonna have a scaling policy by step, simple scaling. I don't see any predictive scaling here. I think that there's something more advanced and more powerful than regular EC2 instances like this one, Omaro. Okay, so right now, if I take a look at this guy, it's already creating instances for me. Remember that the minimum and desired capacity is 2. So if I click here, when I says, and I click here and I say activity, I have 2 instances here that were launched. Okay. And instance management, I have 2 guys here that are healthy. Okay. So right now, if I come to this guy and I stop one, if I stop one, this one, for example, let me see, let me refresh this. If I stop one of the instances that were created, okay, these 2 guys, if I stop this one, it will create one for me. Okay, I'm gonna stop this one. That means that one stopped working. So auto scaling is smart enough to create one for me. Actually, it's gonna create 2. Okay, so I'm stopping that one. And let's see if they're stopping. They're stopping now. So let's just leave this here and let's wait for auto scaling to create 2 other instances, because these 2 are not healthy anymore, because there were as you can see, it only shows 1. You see, it only shows 1 healthy. So it will, if I refresh here, it will start creating another one for me. Okay. So let's wait for that, right? Let's wait for that to happen. And let's take a look. Oh, it's right there. One is pending and the other one is service. That is how auto scaling works. If for some reason your instance stops working because it's broken or something happens, auto scaling immediately will create one for you. It will match up the desired capacity. So this is how it's working. If I stop those instances again, it will create 2 more. So it will always, meet the capacity that I established at the beginning. All right, guys? So take the 10 minutes break if you're still here, and I'll meet you here at 7:22.
Thank you.
So we continue. Okay, this is the instance metadata. It's the data about your instance. Okay, so once you have once you SSH into the instance, right? If you put this information, you put this this information, you will get the data of that particular EC2 instance, right? So once you connect to the instance, for example, this instance, if I come here, okay, this is terminated. Okay, so I come to this instance, to this running instance, for example, if I just connect to it, right? If I connect to that instance and I type not showing anything.
That terminal?
No, I can connect. I can connect my EC2 instance from here, but I don't see. God, so I'm losing control of my mouse all the time. I don't know why. So let me come back to my instances and choose another instance. Maybe this one, for example. I connect to it. Okay, this one is EC2 user. It doesn't connect either. Let me create an instance real quick. Okay, just real quick, and just use this and this and this and this. Preview and launch. Okay, let me. Okay. So I proceed with that key. Let me just tag it and let me name it new server. Okay. So this is the new server. I'll have the new server here. Then I can connect to the server and see what happens. Do we have an issue here? Oh, it did connect. So if I just type this information like curl, HTTP, and 169 like this, 169, 169, 254, 169, 254, and then I just put latest, metadata. I get all the information that I need from the data on that EC2 instance. Okay. Now, if I want to specifically get, if I want to get, oh my guys, if I want to specifically get the the AMI ID, right? You see right here is here. I can do the same thing, and then I can say AMI ID, and I get the AMI ID, okay? Or if I want to get the public IP4, I can do this public IPv4, and I get the public IPv4. It's right there, right? If I want to get the security groups, I can do the same thing, and then I can just say security groups. Okay. And I get the security group. So I can say security groups, security group. I can do this, for example, see if this works. The files directory. Okay. No problem. Okay, so we have here bash yes. So that returns a name. So maybe if I do this, probably works that way. Okay, I will do echo. Yeah, that works. Okay. Just if I want to get the image ID, I can put here AMI ID. I close the backtick, and then instead of just doing this, I can do image ID, and then I just have that, and then I echo that particular ID. I can say image ID, and then I get the image ID. Okay. Image ID. Okay. So I got that particular thing. This is called in Linux command substitution, this guy here. Okay. I can simply say, instead of using the backtick, I can use this, and it's the same thing. Okay. I can do this, and it's exactly the same thing. Okay. That will give me exactly the same thing. So I can put here the public IP. Public IPv4, and then I just name it public IP. And then if I say echo IP, I get the public IPs right there on the corner, right here. Right here, it's the public IP. All right. So I can do all that in Linux. This is a Linux machine, don't forget that. So it has an ls. If I do ls, I have that variable there. Okay. I can create a file, I can say touch file1.txt, and then if I do ls again, file1.txt is there. I can do some things here. I can say echo, this is an MDC class, and then I can redirect that to file1.txt, and then if I just cat file1.txt, I get that information. This is a class. Miami-Dade class college. And then if I can do the same again, and I can add another file, and I can say, and I love it. But this time I'm gonna use a double redirector because this is the one that appends the file, the text. If I use only one, it overwrites it. So I want to append it. So I do that. I do echo. I add a cat, and I got the two texts. Okay. So I can do a lot of things with this. This is a virtual machine, a Linux virtual machine that has all the information, like any Linux virtual machine. So we can get the latest metadata, or we can get the latest. We can get the latest user data, and then we get all the information that I put in the user data. There's nothing there because we never created anything with this thing here, right? There's nothing there, but that's the user data. If there's user data, what was the instance that I created user data in? The web server, right? Okay. So I can close this guy and try to connect to the web server to see if that's possible. Okay. So I have the web server here. If I just connect to the web server, let's see if it connects now. It doesn't connect. Okay, let's continue. Maybe we visit it later. Probably it takes some time to connect. Okay, so that's how you see the information of your EC2 instance. Okay. Now, CloudWatch for monitoring, you can see, it provides almost near real-time metrics. It's metrics about your EC2 instances, right? If I check my EC2 instances, I can see that there is some movement there. So if I come here to my EC2 instances and I see one of my EC2 instances here in the section that says monitoring, I can see that there's some, there's some performance there. The CPU has been used, okay? Like, 3.7, percentage. And for example, the network packets out, packets in, network in bytes, CPU credit usage, credit balance, all these metrics that you can see in your console from the EC2 instance, okay? Basic monitoring is by default, right? That's the one that I have right now. This is basic. Detailed monitoring this is every 5 minutes, and this is every minute. This is more in detail, and you have to pay for it. So whenever you create an instance, right? If I create an instance, I have the choice to select detailed monitoring. It's enhanced monitoring right here. Okay. If I want, it says additional charges apply. So if I come here, it gives you an overview of how it works if you decide to go for the enhanced monitoring. Okay. So don't forget, CloudWatch is for monitoring, right? And basic is every 5 minutes, is free. And detailed monitoring or enhanced monitoring is every minute. You can even go for 1 second, every second, but that's a high resolution. That's going to cost you more, and you can customize that. But by default, the ones that are already created is 5 minutes for basic and 1 minute for detail. Okay, this is a summary of what we saw before. Enables you to run EC2 instances, right? Windows, a Linux virtual machine in the cloud, EC2 from AMI, instance types, security groups, user data, instances are backed by EBS, Amazon CloudWatch, all those services that we saw before, okay? Now, the next part here, we don't have to show a demo, okay? So in Introduction to Amazon EC2 Instance, it's gonna be lab 3. You will launch and configure your first version machine that runs on an Amazon EC2 instance. I'm sure that that's not going to be your first. I'm sure that some of you, many of you already did that and in your own time. Okay. So you're going to launch your Amazon EC2 instance, monitor your instance, update your security group and access the web server, resize your instance type and EBS volume, explore EC2 limits, and test termination protection. Okay. So by the end of the lab, you will have launched an instance that is configured as a web server. This is the final product. View the instance systems log, reconfigure a security group, and modify the instance type and root volume. Okay. So you can do this at home. Okay. So this objective is to demonstrate that you understand the differences between building a deployment that uses Amazon EC2 instance and using a fully managed service, such as RDS, to deploy your solution. Okay, guys, we don't have much time to do this. I wish we had more time, but I can just give you, let me see if I have, okay, let me see something here. I can put this video here. Let me see if this video shows here. This doesn't have a video. Okay. So, too bad. Okay. So between Amazon EC2 or RDS, which provides a managed service? Between Amazon EC2 and RDS, which provides a managed service? Which one?
RDS.
Yes.
RDS, right? And what does
Yes.
managed service mean? What does managed service mean?
Platform as a service.
I'm sorry?
Someone else is running it for
Don't
you.
worry about patching, operating
Patching,
system,
installation.
arrays, backup.
Managed is that everything is taken care of by AWS. That's what it means. Okay. So Amazon RDS provides a managed service. Our Amazon RDS handles provisioning, installation, and patching, automated backups, restoring snapshots from points in time, high availability, and monitoring. That's exactly what a managed service has. All of that. Okay. Name at least one advantage of deploying
Quick
Microsoft
question.
SQL
I
Server
have a question.
or
regarding
Amazon EC2
Point
instance.
number one.
What is one advantage
I
of
have
his?
a question. Denise.
I'm
We
sorry.
What is
didn't
the
go over
difference?
this.
I'm sorry.
Where's the difference? Denise, tomorrow.
Okay.
Where's the
Let's
difference between managed RDS and fully managed DynamoDB?
Okay, remember that when you create RDS, you have to select and you have to configure everything, right? You have to do a lot of configuration. You don't have to, worry about the underlying infrastructure, but you have to configure it, right? That's why it's not fully managed. It's managed, but not fully managed. DynamoDB, you just create the table and you select the writes per second and reads per second. That's it, nothing else. And then the rest is taken care of by AWS. Okay? That's why it's fully managed. Okay. So managed, AWS has a lot of, most of the things is done by AWS. But don't forget that with RDS, you don't have to provision anything, install anything, patch anything, back it up automatically. You have manual backups, right? You have manual. What makes it not fully managed? because you can manually back it up. Okay, with DynamoDB, you don't have to do any of that. DynamoDB is highly available by nature. Monitoring is already there. Restore snapshot, you don't need that. You don't have to automate backups. It's super highly available. That's what makes it fully managed. With RDS, there's some stuff that you need to do, right? That's the difference between that. Okay, someone said that we didn't cover something in class. What was it?
Thank you very much.
What was it? When I show this second
SQL
question,
Server.
okay, a SQL Server is
Database.
it's an engine.
Microsoft database.
The Microsoft.
It's an engine,
SQL.
a database engine supported by RDS. When we get to databases, we're gonna see that SQL Server is a database, right? Software, but it's also supported by RDS. So what is one advantage of deploying SQL Server on Amazon EC2 instead of RDS?
Full control. You're gonna
More
have full control.
Yes, more control.
But we're gonna pay more, right? Anyway.
Not necessarily. Not necessarily. Probably you pay less. But it's not managed. So that's the bad thing. Okay. Probably in the long run you will pay more, probably, because you have to do the installations, patching, automated backups, restoring,
including the product, right?
The product, yes.
Yeah.
Yes, you have to bring the license.
The license.
Yeah. It has a license, right?
Azure has a 40% discount to migrate on-premises SQL Server to Azure Cloud.
Okay, good. So Amazon EC2 offers complete control over every configuration, the OS and the software stack. So that's the advantage. Okay. What advantage does the quick start provide over manual installation on Amazon? This is very common sense question. If you have a quick start, you have a guidance, right? Guidance, and you have a software that helps you install everything. Whereas manual, you have to, you don't have a guidance, that much of a guidance, and then you have to do it manually. Quick start is more automated. Okay. It's built into the design. Right? Which deployment option offers the best approach for all use cases? When it says deployment options, they're talking about software as a service, right?
Platform as a service.
Platform as a service, things like that. Well, the answer is neither. It depends.
Depends.
On your needs.
Yes. Okay, depends.
So there's no correct answer or incorrect answer, right? If your company doesn't care about control, then going for software as a service or platform as a service is good. But if your company cares about control, then infrastructure as a service is the way to go. So it depends on your needs. Which approach costs more, using Amazon EC2 or using RDS? That's the question that someone asked me before.
Mm-hmm.
What do you think?
EC2 costs more.
EC4.
EC2 costs more.
EC2.
Costs more.
There's no right answer or wrong answer. It depends.
It depends.
Managing the database deployment on Amazon EC2 requires more customer oversight and time. If time is your priority, then Amazon RDS might be less expensive. If you have an in-house expertise, Amazon EC2 might be most cost effective. Okay, so it all depends. Right? Questions?
Depends of the customer.
So here are the answers again. Just in case you want to read it, just take a minute and read it. Okay. Amazon EC2 cost optimization. Okay. So Amazon EC2 pricing models, we have on-demand instances, right? You pay by the hour, no long-term commitments, eligible for the AWS free tier. Okay. Okay. When do we use on-demand instances? When you know that there's a trend, is for predictable patterns, right? Predictable patterns. You pay by the hour, no long-term commitments. Remember that you have a long-term commitment when you go for a reserved instance, right? So it's flexible. On-demand is flexible. It's low cost, right? They're gonna work only when there's demand. If there's no demand, they're gonna be working, let's say, low capacity, not intense capacity, right? Now, spot instances is spare capacity that AWS has, and they put it on auction. Okay. Let me explain this to you. You pay, you bid for spare capacity, AWS. So you bid for that, you put a price, you get it, right? Now you have a problem. The problem is the following. If someone outbids you, you lose the EC2 instance. It's super cheap. You can save up to 90%, right? It's super cheap. But if someone outbids you, you have 2 minutes to take action. 2 minutes. You're gonna get a notification telling you that you have 2 minutes to take action. This is where you have to run, back things up, save everything you need to save if you care about your EC2 instances. So these instances are good for testing. If you're testing, you have nothing to lose. Okay? Because you're just basically using dummy data and things like that you don't care. Okay? But if you have something important with spot instances, be careful with that. You may lose everything. Okay? So you run the instances as long as they are available and your bid is above the spot instance price. They can be interrupted by AWS with a 2-minute notification. Interruption options include terminated, stop, or hibernated. Prices can be significantly less expensive compared to on-demand instances, and good choice when you have flexibility in when your application can run. Okay. Now, reserved instances, you have full, partial, or upfront of no upfront payments for instances you reserve. Discount is on an hourly charge for the instance. Okay. And it's a 1 or 2 year or 3 year term contract. So be careful with that too. You're going to be locked in a contract for 1 year or 3 year term, but you're going to be saving a lot of money. And this is when you know how your trend is going to be for the next 1 year or 2 years or 3 years. Okay. Dedicated host is only for you, right? It's a server with EC2 instance capacity fully dedicated to your use. No one else can use it. And dedicated instances run in a VPC on hardware that is dedicated to a single user, because when you have instances, if it is a shared instance, other users will use that hardware as well. Okay, because they're distributed in the same racks, things like that, in the same location, things like that. But when it's dedicated to you only, it's only for you. Now, you may ask me, Professor, what's the difference between dedicated hosts and dedicated instances? Well, let's imagine that a dedicated host is a hotel and a dedicated instance is a room. Okay? So a dedicated host can have different rooms. That's how you can see it. Okay? The scheduled reserve instances are instances that you purchase, right? You purchase capacity that is available on a recurring schedule. For example, every day, you turn your instances you turn them on at 9 a.m. and just turn them off at 5 p.m. every day, or probably one day a week or something like that. This their schedule, right? And they are in the 1 year term, right? So you may see reserved instances, but you also may see RI. So when you see RI, that's reserved instances, right? Okay, per second billing available for on-demand instances, reserved instances, and spot instances that run Amazon Linux or Ubuntu. That's per second billing. The rest is per hour. Okay. So the pricing model benefits on-demand instances, low cost and flexibility. Spot instances, large scale, dynamic workload. Reserve instances, predictable insurance, ensures compute capacity is available when needed. Is when your traffic is predictable. And dedicated host, you save money on licensing cost, help meet compliance and regulatory requirements. Okay, so you have to have licensing, right? Licensing. You need to have
Professor,
licensing, but you save money. Yes.
Professor, is possible to migrate from one of the model to the other one? For
Yes,
instance,
you can have a combination of them. You can
okay.
have 2 on demand, 3 spot, 6 reserved. You can have that.
Migrate if you are in the reserve instance and you want to migrate to dedicated host, even you are in the term of the contract, is possible, or you have
For the reserved ones, you will have to sell them because you are in a contract. Remember, you have a 1 year or 3 year contract. You're not supposed to break that unless you sell them. You can sell them.
okay.
You can sell them, but you're gonna be charged. I think it is like 10% of the upfront fee. Okay. Um, so you have to be sure that what you're buying is what you need. Okay, that's very important. And you go with these guys when you know that your traffic is predictable throughout the year, right? And you go with these guys. But if something happens, let's say that you have to shut down your company for something happens, and let's say you bought $3,000, $4,000, $5,000 in capacity, you have to find a way to sell them. It's like when you have a lease, right? A lease, a car lease, and then you want to get rid of the lease. What do? You sell it to someone else, and the person will take on the lease if it is, if the person will continue financing the car, or you can sell uh, that car at a price and then pay off your debt with the bank, something like that. Um, yeah, very, very careful we have to be with this because this is a contract, right? Like any other contract, right? So on demand is for short, spiky, unpredictable workloads. Short, spiky, unpredictable workloads. All right. So if you know that your traffic is, gets really, 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 really spiky on Thanksgiving, right? And only in Thanksgiving and the holidays and things like that, on demand is the way to go. Okay, because it's based on the season. But if you have, spiky traffic throughout the year, you're selling a very hot product that people like it, and then you can go for the reserved instances, right? So you don't have to go with the on demand. So short term, spiky, unpredictable workloads and application development or testing. So this is a good use case when you're developing and testing. Spot instances is for application with flexible start and end times. So pay attention, guys. If you see that the company is looking for instances that can be started or ended at any time during the day, that's a spot instance. So this little chart that you see here with the use cases is very important because out of these points that you see here, you may have several questions in the exam. Okay? So they may take this out of this context and make a question out of that easily. You say the company is looking for flexible or looking for instances that they can use on certain days during the year when the traffic is spiky, right? And they don't have a predictability very clear. Okay, so they're not sure when the traffic is going to be spiky, so it's unpredictable, and they can use those EC2 instances for development or testing. So what kind of instances would they go for? And then they could put on demand, spot, dedicated hosts, dedicated instances, or you can do reserved instances. The answer is on demand. Okay, be careful with that. Okay. Now, spot also only feasible and very low compute prices, and when they have needs for large amount of additional capacity. So if they need additional capacity and they are desperate about that capacity, spot instances is the answer. Okay. Reserved instances, steady state or predictable usage workloads. So it's the opposite of on demand. Okay, it's the opposite. The on demand is unpredictable, spiky workloads, right? And short term, and spot instances is, reserved instances is steady state and predictable. Okay. Applications that require reserved capacity, including disaster recovery, users able to make upfront payments to reduce total computed costs even further, right? Dedicated host, you bring your own license, right? You have to bring your own license, right? It has to be compliant, and it has to be, limited to the regulatory restrictions, right? Usage and licensing tracking, and control instance placement. So you have a lot of benefits with this guy, and it's for highly sensitive workloads. Okay, governments use dedicated hosts. So this is very, very dedicated for specific companies, specific organizations that need this type of instances. Highly sensitive, okay? So this is important. Cost optimization, right? The 4 pillars of cost optimization. We have 4 pillars here. Guys, I may start opening exams based on the PowerPoints that we see in class. So soon you may get, you may start getting exams. And also, don't forget that tomorrow you're gonna have exam number 2, okay? Number 2 tomorrow, okay? And 1 every day. For the students that were not here at the beginning of the class, every day you're gonna have an exam. So far, it's like 3 people have taken the first exam and no one has taken the second one. So please make time to do it. That, like I said at the beginning of the course, at the beginning of the class, exams will give you a better idea of the actual exam. If you don't take an exam for the actual exam, you would not know how they ask questions. Okay, that's very important. How do you save money? By choosing the right size. You may choose a size that is not in accordance to your capacity. It could be lower or it could be higher. So you have to be careful. You have to know what size you need to choose. Increased elasticity, okay? That will save you money as well. Optimal pricing model and optimize storage choices. You have to go for the option of storage that gives you the best choice, right? So how do we choose the right size? You notice that when servers can be either sized down or turned off and still meet your performance requirements. Sometimes you have services that are running and they're not necessary, okay? So that's very important. With increased elasticity, you design your deployments to reduce the amount of server's capacity that is idle, but by implementing deployments that are elastic, such as deployments that use automatic scaling and to handle peak loads. You see the automatic scaling policy that I created, or what I did, that it created 2 EC2 instances for me, okay? Based on the CPU, now I have to create a policy based on the CPU, right? And then I would choose a specific target. When the CPU is this percent, let's say 80%, create 1 more instance. If it is 20% or lower, then remove 2 instances. So that's the way, with that elasticity, you can save money. Optimal pricing model, you recognize the available pricing options that you have, analyze your usage patterns so that you can run EC2 instances with the right mix of pricing options. Now, optimize storage choices. You analyze the storage requirements of your deployments, reduce unused storage overhead when possible, and choose less expensive storage options if they can still meet your requirements for storage performance. Okay, that's very important. Now the right sizing, right? You provision instances to match the need, right? CPU, memory storage, and network throughput. Select appropriate instance type for your use, right? Guys, if you choose an instance that is an instance type that is not the correct one, you need more, you can change the instance type. You know, again, you don't have to create another EC2 instance. You can change the instance type, right? If you have to minimize it or just make it lower, you can choose a lower instance type, right? You can use the CloudWatch metrics to see, you know, the movement of your EC2 instances, okay? How idle they are and when they are idle, okay? So if you see that your instances are, you know, on a regular basis, they're idle after 5 p.m., you can stop them, okay? You can stop them. Or probably use a smaller size, right? You don't have to use the same size because you're wasting money. So the best practice, right size, then reserve, okay? If you know that your traffic is predictable, right? Get the right size and reserve if you want to save money, all right? You can stop or hibernate Amazon EBS backed instances that are not actively in use, okay? Amazon EBS backed, it means that when you stop it, you don't lose the data, okay? When you stop it, you still keep the data. For example, non-production development or test instances, they're not in production. Why would you have them running? You don't need that. Stop them, okay? Like the ones that we have right now in our computer, okay, in our account, in a console, in AWS. If you're not using that, what's the point? You know, stop it. That's a non-production EC2 instance, right? You can use automatic scaling, right, to match your needs based on the usage, and you can automate this process, right? You can leverage the right model for your use case. Consider your usage more patterns, optimize and combine purchase types. So you can have, it's like I told Florentina, you can use on-demand instance and a spot instance for variable workloads. Okay, so you can combine that. So if you have, for example, one section of your application has a steady workload, and then you can use reserve instances for that type, right, for that section. And there's another part of your application that has, you know, unpredictable pattern, traffic pattern that you can use on demand. Or maybe you can use more spare capacity from AWS that you can use spot instances. So, you know, you can have a combination of different, you know, types of instances, right? And, you know, perform better, right? And they give you a solution here, consider serverless solutions, AWS Lambda. So AWS Lambda will accomplish the same as EC2 instances and even better than that. So if you have people that are trained and they know how to use Lambda, right, you're gonna save more money if you use Lambda. Okay. Optimize storage choices. You can reduce the cost while maintaining storage performance and availability, right? Resize EBS volumes. You can resize the EBS volume. You can choose a volume that is smaller than the one that you have now, or you can use a volume that is higher. It has a higher capacity, okay? So by changing the EBS volume types, you can meet performance requirements with less expensive storage, right? For example, you have an EBS throughput optimized HDD, ST1, the storage typically costs half as much as the default general purpose SSD. So that HDD is called cold storage. So you use that type of storage, HDD, when you don't have a lot of traffic, okay? So it's less frequently accessed than general purpose. General purpose is SSD, solid state drive, that costs more. Whenever you go SSD, costs more than HDD, okay? If you're no longer using your EBS volume, delete them. Delete them. You don't need them. Okay. But before you delete them, back them up. Okay. You don't want to lose that information. So be careful with that. Okay. Identify the most appropriate destination for specific types of data. Does the application need the instance to reside on Amazon EBS? Amazon S3 storage option and with lifecycle can reduce cost. Okay, when we get to storage, we're gonna see Amazon S3 storage. You have a lifecycle policy. Let's say that they have files that are not accessed after 30 days. So you have one class called standard, S3 standard, right? Frequently accessed standard. You can keep those files on standard storage, and after 30 days, you can move them to an infrequent access. That will be S3 standard IA, infrequently accessed. After that, after 60 days, for example, you can put them in Glacier. Glacier is an archiving system, an archivist storage class for files that are never or almost never accessed. So you can keep them there for 365 days if you want to, or maybe more. That's a life cycle that you can create, right? When you upload the files, and then you don't have to worry about that anymore. This is not a manual process. You configure it and then it will do it by itself. Okay, it's a life cycle. With measure, monitor, improve, your cost optimization is an ongoing process. You are constantly looking for ways to save money, right? You may find ways to save money along the way, right? That's what I said before. Enforce allocation tagging, right? Enforce tagging. You can create policies that force tagging on services. Why? Because you can identify them faster, and then you can see by tag how much you're being charged per service, right? You can define metrics, set targets, and review regularly. Encourage teams to architect for cost. So one of the questions that when someone asks you, how would you architect this? One of the answers that you should give is, I need to find the most cost-efficient solution, okay? Apart from making it highly available, you have to make it cost-efficient. We're not looking for having a lot of services and then have the best architecture and forget about cost. Cost is very important. One of the reasons why people don't move to the cloud is because they don't know how much they can save on cost. They think that they're going to pay more. Wrong, they're going to pay less. But cost is what moves companies. If you're finding a solution that you're paying 50% less, that person's not going to think it twice to move to whatever they have to move. So cost is very important. So assign the responsibility of optimization to an individual or to a team. So make a team that's going to be working on optimization of the money, of whatever they're trying to accomplish. Okay, a dedicated team for that. That's what they recommend. Okay, so we saw the Amazon EC2 pricing models, right? We saw the on-demand instances. And can someone tell me what I use on-demand instances for? When? Can someone tell me?
Spiky, unpredictable pattern.
Right. So short-term, spiky, unpredictable workloads. Good. Reserve instances. Can anyone tell me?
It's a positive, yeah, on demand. For sure.
Guys, you here? The only person that I have here is Mr. Odmaro. I don't have anyone else here.
We're here. I'm just.
So when do we use reserved instances? When?
You don't want to lose anything.
You don't want to lose anything? But what type of traffic? What is the use case? When do we use reserved instances?
Predictable traffic.
Steady.
Predictable
traffic.
Predictable pattern.
Right.
Low.
Okay, when do we use spot instances?
Flexible start and end times in apps with
Flexible
low
start and end
compute
times, good.
prices.
When you need you know, extra capacity, right? Okay.
And it's good for test?
For test is on demand.
On demand, okay.
On demand is better for, you can use testing, spot instances for testing too, but also on demand, okay?
With the, hey, Professor, with the on or with the spot instances, you said that's like a bidding.
It's
and
bidding.
you can combine that with like a dedicated. So like you put your mission critical stuff on like a dedicated or a reserve, and then anything that can be, I just want to, because you said you can kind of use both at the same time, right?
Yeah, you can.
So
Yes.
yeah, with the spot, you could save a lot of money.
Yeah.
But yeah, it's all about the bids. Does the bid go like every minute, or how is that? Is there like a dashboard, or is that like?
I cannot tell you. It depends. It depends.
Yeah.
I cannot tell you. You would know when someone outbids you, for sure.
Okay.
It notify you. It's like eBay. You know, when you auction a product on eBay, it's not every minute or every second. It's just when someone decides to outbid you. You know.
Oh, I see. Okay.
But when you are outbid, you have to move fast. So you have 2 minutes, right? So they may be interrupted after 2 minutes. Okay, because someone just paid more than you. Okay.
Yep.
Okay, you can save a lot of money, you know, over on-demand instances with spot instances. We're talking about almost 90%. Okay, it's saving a lot of money, but you're running a great risk, a big risk of losing everything. What are the 4 pillars of cost optimization? Right size, increase elasticity, optimal pricing model, and optimize storage choices. Okay, guys, the takeaways are very important. I would say that it is probably, I would say 70% most important than anything else. The takeaways, because it's the summary of that section. All right. Container services. Okay, so we have, this is a method of operating system virtualization. Okay, you're virtualizing your operating system. Benefits: repeatable, self-contained. That's one of the main benefits, self-contained. It means that other instances that are in other containers, they don't have any dependencies. Okay, if they go down, I don't have to go down. We're self-contained, right? And the software runs on the same in different environments. So we have the same EC2 instances in different containers, right? And develops laptop, test production, things like that. And it's faster to launch and stop or terminate than virtual machines. Okay, so basically you can create containers, and then you put the virtual machines inside the containers. So actually you're running containers. Okay, but you know, you're gonna have you're gonna be working with server full applications. They need a server. Okay, so you have your application dependency configuration hook into the OS. So things are inside this guy. This is your container. You're gonna have everything that you need inside that container to run the application, and then another container is gonna have the same thing, and another container, and another container. If the container goes down, right, go down, the other ones will not necessarily go down. Okay. So Docker, I'm sure that many of you know Docker. Okay. So it's a software platform that enables you to build, test, and deploy applications quickly. Most of the interviews that you guys can have currently, they will ask you if you know about Docker. That's a pretty standard question. Okay. If you're applying for a development position or engineer position, they're gonna ask you about Dockers because it's very popular nowadays, super popular. Okay. You can run containers on Docker, right? Containers are created from template called an image, right? I remember that I show you guys an image repository. Remember Docker Hub? Docker Hub, you can find images there. You can find images for Windows, images for Linux, images for Amazon Linux as well. And a container has everything a software application needs to run. So it contains the library, the system tools, the code, the runtime, everything you need. And right now, containers are super, super popular in the development world. Super popular. Okay. And the good thing about containers is that they are repeatable and self-contained. Okay. So you don't want your application to break, and I mean, you don't want an application portion to break and break the entire thing. You don't want that. You want things isolated, loosely coupled. You don't want everything tightly coupled, because if something breaks, it will break the entire thing. You don't want that. Okay, you want to break, you don't want to break anything, but you want something to break on itself and self-contained. Okay, that's the good thing about microservices. Okay. So
That's a good thing about Microsoft. What?
Microservices.
Oh, okay.
You have small portions of your application, and then you can work individually on them, and then just bring them together and have the application fully functional. Is that, for example, one team is working on the logging feature. That's the logging feature. Okay. Other team is working on the interview. Let's say that the application is for customers that are being interviewed. You're going to work on the interview section. Another team is going to work on the survey question. Let's say that you are surveying the customers after they go through the experience with the application. You want to survey them. So you're going to create the surveys and things like that. So you want everybody working on a portion that is not depending on the other, but they can be separated, right? And they can be isolated from each other. So that's microservices, right? And then you bring them all together, and then they work as a unit. All right. I think that's called synthesis and analysis. Two different processes that you can split the application into small portions, and then everybody will work on those portions, right? Dedicated teams, and then you bring everything together back again and have the whole thing working. Okay. So here you have 3 virtual machines on 3 EC2 instances, right? You have the VM, the virtual machine 1, 2, and 3. You have application 1, application 2, 3. You have the bins and the libraries here, and then you have the EC2 instance guest operating system, right? That will be Linux or Windows or whatever operating system you choose, right? So this will be 3 virtual machines, right? Now, if you have 3 containers here, you have container 1, and you're running containers on Docker, okay? So you have container 1, container 2, container 2, application 1, application 2, application 3. And then you have bins, library, bins, library, bins, library. And then you have the EC2 instance guest OS. So you have 3 separated virtual machines here, each one using the guest OS, right? Here we have only the guest OS, and on top of that, we run the containers in Docker. So this is far more efficient than this, okay? And each container is, self-contained, right? Self-contained here, self-contained, right? You can create instances with the ECS service, which is Elastic Container Service. You create instances there, right? And you can run an application on each instance, on each container, right? On top of the guest operating system. And everything's going to be on top of the hypervisor, and then the host operating system and the physical server. But this is, this is everything that has to do with AWS, okay? That's part of the AWS infrastructure, okay? Good. So Amazon Elastic Container Service, Amazon ECS, that's the guy that we're talking about, right? It's, guys, you have no idea how much AWS enriched this class. This is much more comprehensive and encompassing than the previous curriculum. probably you don't know because you haven't taken this class before, but I can tell you, I've taught this class numberless times. And believe me, they have improved this a lot. They have put a lot of content here that is even for the solutions architect exam. Okay. So this is a highly available and scalable, fast container management service. The key benefits orchestrates the execution of Docker containers. Okay. It maintains and scales the fleet of nodes that run your containers and removes the complexity of standing up the infrastructure. Okay. That complexity is found using EC2 instances separated by themselves, like, on their own. The containers, you have less complexity and it's more effective than having the EC2 instances like this, right? This introduces more complexity than this. Okay. Just the fact that you have to use the guest OS here and the guest OS here and the guest OS and here only one time, that makes it more simple. Okay. It's integrated with features that are familiar to Amazon EC2 service users. So guys, if you're using EC2 instances, you know that you're gonna have velocity load balancing, security groups, EVS volumes, and IAM roles. Because you created instances, but you're gonna run them in containers. It's a different environment, but it is an EC2 instances anyways. So orchestrate containers. So we have, go ahead.
The cost analysis on building an EC2 just outside of a container and adding, because you're adding under that a hypervisor and a OS.
No, I'm not adding that. That's already there.
Right? Oh, that's already there. Okay.
I don't have to add that. That's already there. That's AWS infrastructure.
Oh, okay.
Whenever you create an EC2 instance, it is put above the hypervisor. I don't have to do that. That is done by AWS.
In any way, it would be a benefit because you're using the computing power of one OS to handle 3 instead of the computing power of 3 OSs.
Correct.
Under 3 separate applications.
Correct.
All right, thanks.
So you have Amazon EC2 ECS, orchestration containers. You have request to run containers right here. And then you have the Amazon Elastic Container Service right here. And then you have container A, container B, that has one EC2 instance. This one has one EC2 instance. And then you have another here, EC2 instance. So it's an orchestra, okay? An orchestra here, right? Another cluster, this is a cluster of EC2 instances, right? And you're running this EC2 instances inside a container, inside the service container service, right? And you have this container A, container B, right? So these are gonna be in this container service as well, all right? So when you have, let me see if I can go here and then choose, let me choose here, Elastic Container, let's do ECS. And then I get this ECS, right? And then I'm gonna create a cluster. I can choose EC2 Linux plus networking or Windows. I'm gonna choose this one. Okay, and then I'm gonna, next step, I can choose on demand or spot, right? Let me choose on demand for now. So I can do here T2 micro. I don't think the T2 micro is here, and the T2A micro, this T3. T2 micros right here. So manually enter desired instance type. Number of instances, I'm creating 1. And the root value size, let me put A. Okay, well, I have to be 30 by default. I didn't want to go that high. So the image instance is gonna be this one. And then the key pair, maybe I want to use, this is the one that I created today. I don't want to use SSH. The VPC, I'm using the default one, which is this one. The subnet, I'm gonna choose this one, right? And then the security group, I'm gonna choose the one that I just created today. Where is it? Where is it? I choose anyone. It doesn't matter.
Down there. Web server change.
It doesn't matter. I'm gonna use this instance role, and I'm gonna just name it. No tag for now. CloudWatch container insights, enable container size. I don't want that. So there's an error on the page. What happened? Okay, the name, my new container. Okay, so I can just create that and create the container, and it begins to create the container for me. And by the way, it's using CloudFormation stack in the background because that's the one creating the EC2 instance for me. Okay, so this is going to create an EC2 instance and it's going to run it inside the container. Okay, but in this case, I just wrote one, that's the desired number of instances, right? I could have written 3, right? And availability zones, it's going to use 1A, 1B, 1C, 1D, 1E, 1F. Those are the ones that are available in this VPC that I chose, right? Okay, so that's going to be working there. It already worked. You have here the instances. I have active right now. I have a cluster, right? This is the cluster. Where is the?
When you say a cluster, I'm a little confused. What's happening in the back? You have a high availability solution?
As a cluster is a group of instances that you create.
And they're all in one availability group? I mean, availability zone.
Yes. It depends on what you choose. Whatever you choose, all of them are going to be there.
And you choose them to be in separate availability zones?
Actually, I didn't choose the zones. I just choose the VPC. And then it will update that.
But if you had a VPC, how could you, the cluster to me, it's a group of resources for high availability purposes, correct?
Correct. That's correct.
How is this providing me availability, high availability?
This will put them it will make them available in different availability zones. It will put them across the VPC.
Ah, that's right. Okay.
But I'm just creating one. I just created one, so there's no high availability there. I have to minimum 2. You know, minimum 2. So I have the instance here. It's already here, it's active. So it's running in this container instance. This is a container instance. If I take a look at this, I will see that they are in my EC2 instance section, but it's going to be a container instance. So it's basically an instance, but it is running inside a container. Okay. And then I can just create task definitions, what I want to do with the task. I can create a elastic load balancer. I can do so many things with this EC2 instance. Okay, guys, it's 8:31. It's time for us to break for today. And, you know, we're going to continue on Wednesday. We stop here at slide 62.
Okay.
And then we're going to continue on that. Don't do the labs today because we haven't finished yet. Okay. And I haven't opened either. So when we're done on Wednesday, I think that I'm going to do some activities and I'm going to give you some assignments so you can practice more this compute thing. Okay. So I wish you the best. Don't forget that there are exams that you need to take. Okay. Don't forget that. And, you know, keep at it and don't stop. Okay. So I will see you on Wednesday. The video is going to be available as soon as we finish this class. Okay. Does anyone have any questions?
I have a question.